going to discuss about the topic relations. What is relations and what are the types of relations and with the examples. Okay, now we can enter into the topic. Have you heard about relations? Yes, from the starting onwards, we have heard about relations, blood relations. She is my brother. That is relation. She's my wife. She's my daughter. Everything is relation. In maths, what is relation? Yes, that is a relations. We can say in mathematics that is also relation, but not only that is also relation. We can say in numbers. If having 35 students, among 35 students, I want to pick up who are all pass marks. That is a relations. I'm checking that too. Who are all pass. Pass mark is 40, 40, comma persons. That is the relations. So we can notate in mathematical rotations. A comma B belongs to A cross B. Cross is represent Cartesian product. What is Cartesian product? Other than product. In product we have multiple 2 into 3, 6. But here 2 into 3, 6. Just represented 2 comma 3. That's it. Okay, A comma B belongs to A cross B, where A belongs to A, B belongs to B. If I take A as one student, B is pass mark, it is 50. So that is A comma B, scoring marks. Okay, now I am going to discuss the topic types of relations. What are the types of relations? Types. Why we need types? If I am choosing relation between A and B two sets, I am say A comma B, but I am choosing in the sets. I am choosing the numbers only in A, not other than. That's the types of relations. A cross A. Types will be denoted for A cross A, same sets. Okay. Now types. What are the types? Empty relations. What is empty relations? In my I'm choosing a one boys school. So in that school I'm saying A is sister of B, but A comma B both uh, are in the set A, not in B. So A comma B both are boys. So if I'm choosing A comma B, A is sister of B, it is wrong. So there will be no possible. So that is called empty relation. Next, universal relation. What is universal relation? Universe means it will be there, yeah, everything. So that name is universal relations. In practical life, we can say, I'm in school students, everyone belongs to below 18 age. Yes, 18 age below only there will be a school students. So like that, I'm getting universal set, universal relation. Now I'm having three relations: reflexive, symmetric, transitive. If these three conditions satisfies, then the relations should be equivalence relations. How we say reflexive, symmetric, transitive? What are they? If I'm choosing reflexive, have you heard any movies like psychopath movies? For example, in Onion movie, so Vikram plays that he is the onion, he is the Ambi, he is the Remo. So he is related to his. Who is Remo? Same character. Who is onion? Same character. So A is related to A. That is called reflexive. A is related to A. Next, symmetric. If I'm choosing A related to B and B related to A. For example, in Vijay movie, Nanban. So his every friend should be, if A is friends to B, then B is friends to A. That is called symmetric. What is transitive? If you have heard drugs, okay, Vikram movie. Likewise, we can say it in example Vikram movie. Here, Fazl is searching Vijay Sethupathi. So A is related to B, but Vijay Sethupathi is head Rolex. So B related to C. He want to capture head of the drugs. So automatically A related to C. That is called transitive. If three conditions is satisfied, then this relations is called equivalence relations. For example, in our old empire, we can say Punnin Selvan. So there are three characters: Arunmoli, Aditya, Kundavi. This is Arun Aditya is related to that empire. So it is reflexive. Then Kundavi is related to Aditya. Aditya is related to Kundavi. That relations is called symmetric. What is transitive? A is related to Aditya one is related to Kundavi and Kundavi is related to Arulmoli. Arulmoli. So Aditya and Arulmoli also has a relations. Now that relations is called equivalence relations. Next, I'm going to show some problems. Say about one problem. Let T be the set of all lines in the plane. Set of all lines. We having one set with the lines. Okay. R be the relations. We having one set with the lines. All set of lines. Likewise, parallel lines, perpendicular lines, straight lines, everything. So in the plane that is it or be the relations it is defined as one relations is defined. What is that relations? L1 comma L2. L1 is perpendicular to L2. It is a relations. Okay, in the set we are having L1 and L2. L1 L2 it is perpendicular. We have said show that R is symmetric. We have to show this relation is symmetric but neither reflexive nor transitive. Neither and nor means opposite. Both are negative. So not reflexive, not transitive. So now we are going to see reflexive. Reflexive means A related to A. L1, comma L1. It is should be a particular perpendicular line. If I am taking L1, again L1 does not be a perpendicular, it should be a parallel. So it is not reflexive. Next it is a symmetric. Symmetric means L1 comma L2 A related to B. So L1 comma L2 is perpendicular. It is given in the conditions. Next B related to A, we have to prove L2 comma L1 is also a perpendicular. Yes, definitely L2 comma L1 also perpendicular. So symmetric is true. Next, transitive. L1 comma L2 is perpendicular. L2 comma L3 is perpendicular. L3 is perpendicular. Then L1 comma L3 should be perpendicular. No possible. This is L3. This is L1. It is not perpendicular. It is parallel line. So it is not true. So symmetric only perpendicular. Hence with this sums is proved. Next problem. First we prove that equivalence relation. Next we have to find the elements in A. Okay. First we prove that equivalence relations. Here it is given a polygon. What is polygon? Have you heard about polygon? Yes, it should satisfy three conditions. It is two-dimensional product. It should be not a three-dimensional. Okay, that is polygon. It should be closed, not a open. It should be diagram should be closed surface. Next, it is it just should be a straight line. Circle is not a polygon because that is not a straight line. So likewise, we choose the polygon shape. Here I am choosing a triangle. P1, P2, P3. Choosing three sides triangle. Given P1, comma P2 have a same size, it is given first part. Now I am going to show it is equivalence relation. Equivalence relations means it should be satisfies three properties: reflexive, symmetric, transitive. Reflexive. In that reflexive, A related to A. A related to A means P1, comma P1 related to. These are relations. P1, comma P2 is we can write as such that P1 and P2 P1 comma P1 have same size. So P1 comma P1 also having same size. So it is reflexive. Next is symmetric. Symmetric means A related to B, B related to A. P1 comma P2 have same size. P2 comma P1 P2, comma P1 also having a same size. So this is a symmetric transitive. If I am choosing P1, P2 have same size, P2, P3 having a same size, then P3, comma P1 also having same size means it is transitive. Yes, it is satisfied P1, P3 also having same length. So it is a equilateral triangle. So it satisfies three properties. So it is an equivalence relations. Next we have to find out what are the elements. And we have to find what are the elements. What is the elements if that I'm choosing a right angle triangle. Choosing a right angle triangle with the sides 3, 4, 5. Okay, that is means P1, 3, P2, 4, P5, 5. Okay, what are the elements should be here? These three spots. I'm saying it is a equivalence relation. All you can say is equivalence relations. So T1 is related to T2, T2 is related to T3, T1 is related to T3. So what is T1? 3, 4, 5. So the T3 also 3, 4, 5. So what are the elements in A? 3, 4, 5. That's it. Next problem. If you like this video, subscribe it for more videos. Thank you.